In this video, we'll write the balanced net ionic equation for SrNO3 2 plus K2CO3, strontium nitrate plus potassium carbonate. So the first thing we do with net ionic equations, we balance the molecular equation. This is the molecular equation. I can see I have two potassium atoms here and just one here. So I'm going to put a 2 in front of the KNO3. That balances the potassiums. Now I have two nitrates, but I have two nitrates over here, and it looks like everything else is balanced. So now we can write the state for each substance. If you know your solubility rules, nitrate's very soluble. Like AQ, because that'll be aqueous, it'll dissolve in water, dissociate into its ions. Carbonates in general are insoluble. They won't dissolve, except when they're bonded to group 1 elements like potassium or sodium. So this will be soluble because we have the potassium atom here, AQ. But this carbonate here is bonded to strontium. So this is going to be insoluble. These two react, it forms a solid. And that solid, it falls to the bottom of the test tube as a precipitate. So we have a precipitation reaction. For the potassium nitrate, that's going to be aqueous. We have a nitrate and a potassium atom. So those are the states for our net ionic equation. Now we can split the strong electrolytes into their ions for the complete ionic equation. Strontium's in group 2, so that'll be 2 plus, and the nitrate ion, the whole thing, is 1 minus. We have two of them. So we'll have our strontium ion, Sr2 plus. I'll write the states later. Let's not do that now. And then 2 of these nitrate ions. Potassium, that is in group 1 on the periodic table. It'll be 1 plus, each one of these. And the whole carbonate ion, 2 minus. So we'll have 2 potassium ions, and then we'll have that carbonate ion there. So these are the reactants in our net ionic equation. In the products, we have this solid here. In net ionic equations, we don't split solids apart. So we're going to keep this strontium carbonate together. It's a precipitate, so we'll keep it together. For the potassium, we said that was positive and the nitrate negative. So we have 2 potassium ions and we have 2 nitrate ions, just like in the reactants. So this is the complete ionic equation. Now we can cross out spectator ions. They're on both sides of that complete ionic equation. When I look at the reactants here, I see 2 nitrate ions. In the products, I also have 2 nitrate ions. Those are spectator ions, and I can cross those out. Reactants, 2 potassium ions. Products, 2 potassium ions. Spectator ions. Cross them out. What's left? That's the net ionic equation for SrNO3 2 plus K2CO3. I'll clean it up and write the states. We'll have our net ionic equation. So this is the balanced net ionic equation for strontium nitrate plus potassium carbonate. If you count the atoms up, they're balanced, and the charge is balanced as well. We have 2 plus, 2 minus. That gives us a net charge of 0. Over here, this is neutral, net charge of 0. This is Dr. B with the balanced net ionic equation for SrNO3 2 plus K2CO3. Thanks for watching.